Okay, this is a video just to take you through the first three circle theorems. The first one states this, that if you take any 2 points on the circumference and extend lines out to the other end, touching the circumference, and from the same 2 points, so this one and this one, let's call them A and B, you take 2 lines going out, instead of going to the other end, that they go to the center, which we'll call C, that this angle here is always half of this angle here. Or if you want, this angle here is always going to be twice this angle here. The way we would write that is if this is going to be x, then this would be 2x. And that's always the case for any circle. These lines need to be straight, they need to be touching the circumference, this needs to be in the center. The sort of question you might get might look a bit like this. This is the center. There is a line. You're told this angle here is, let's see, 60 degrees. This is going to the center, going from the same 2 points and going to the other end, going to the other circumference. So this would have to be half of this. So this would be then 30 degrees. The second one, it's similar. If you have any 2 points A and B, and you take a point, straight line going from the other side, going to the other side, it doesn't matter where you touch the circumference, the angle will always be the same. As long as you're going always from A and B, every single time. So you'll notice our straight line's going from A to B. That means this angle here is always going to be the same as this angle here, is always going to be the same as this angle here. So we can call those the same name. So how might that appear in a question? There's loads of different ways you can get it, but let's pretend that we have this here, and we have this here, and you're told that this is 25 degrees. Then because they're coming from the same point, this will also be 25 degrees. Incidentally, this angle here then would be the same as this angle here, because look, those are coming from the same point as well. Okay, so this happens to be 40, this would then be 40 degrees as well. On to the third one. If you have a diameter, now I'm hoping people know what a diameter is. It's a chord that goes through the center, and you do the same sort of thing. You take your 2 points A and B, then this is always going to be a right angle. So wherever it touches, this is always going to be a right angle. From this rule above, actually, say for example we did one here, because that's coming from the same point, A and B, that's going to be a right angle as well. But if this is a diameter and you have 2 points subtending in from there, it's always going to be a right angle. Sort of question you might see. A couple of different versions of it really. But you may actually get a weird question like this. Let me see, where this is 2x and this is x, and it might ask you then to find x. So what do we know here? This is going through the center, so we know that this is 90 degrees. This is a triangle, this is 90. So these three must add up to give 180. So what do we have? We're going to have 2x plus x plus 90. So what's that? That one plus that one plus that one equals 180 degrees. That means 3x, sorry, excuse my writing there, plus 90 is equal to 180 degrees. 3x is 90, so x must be 30 degrees. That must be 30, that must be 60, and as we know from our theorem, that's 90.